Welcome to SS2 Mathematics. This lesson provides an introduction to hyperbolic functions, a set of functions related to the exponential function that have properties analogous to the trigonometric functions. Hyperbolic functions appear in further mathematics at SS2 and SS3 level and in university level mathematics and engineering. The hyperbolic sine and cosine are defined using the exponential function. Hyperbolic sine, written sin x, pronounced shin x or sinh x, equals e to the power x minus e to the power negative x divided by 2. Hyperbolic cosine, written cos x, pronounced cos x, equals e to the power x plus e to the power negative x divided by 2. Hyperbolic tangent, written tan x, equals sin x divided by cos x, which equals e to the x minus e to the negative x divided by e to the x plus e to the negative x. The defining identity relating them is cos squared x minus sin squared x equals 1. Compare this to the standard trigonometric identity sin squared x plus cosine squared x equals 1. Note the difference in signs. For hyperbolic functions it is cos squared minus sin squared equals 1, not plus. Sin x is an odd function, sin of negative x equals negative sin x. This means its graph is symmetric about the origin. Sin 0 equals 0. Cos x is an even function, cos of negative x equals cos x. Its graph is symmetric about the y-axis. Cos 0 equals 1. Importantly, cos x is always greater than or equal to 1 for all real values of x, with minimum value 1 at x equals 0. This is the shape of a catenary, the curve formed by a hanging chain or cable. The gateway arch in the United States and many suspension bridge cables take the shape of a cos curve. The range of sin is all real numbers, negative infinity to positive infinity. The range of tan is between negative 1 and positive 1, exclusive. The hyperbolic functions satisfy identities that mirror the trigonometric identities, but with sign changes in some places. The fundamental identity, cos squared x minus sin squared x equals 1. Dividing by cos squared x, 1 minus tan squared x equals sec squared x, where sec x equals 1 over cos x. Addition formally, sin of a plus b equals sin a cos b plus cos a sin b, cos of a plus b equals cos a cos b plus sin a sin b. Note, both addition formulae for hyperbolic functions have a plus sign, unlike the trigonometric cosine addition formula which has a minus. Double angle, sin 2a equals 2 sin a cos 2a equals cos squared a plus sin squared a, or equivalently 2 cos squared a minus 1, or 1 plus 2 sin squared a. To evaluate hyperbolic functions for specific values, use the definitions directly. Example, calculate sin 1 and cos 1. E to the power 1 equals approximately 2.718. E to the power negative 1 equals approximately 0.368. Sin 1 equals 2.718 minus 0.368, divided by 2 equals 2.350 divided by 2 equals 1.175 approximately. Cos 1 equals 2.718 plus 0.368, divided by 2 equals 3.086 divided by 2 equals 1.543 approximately. Verify the identity, cos squared 1 minus sin squared 1 should equal 1. 1.543 squared minus 1.175 squared equals 2.381 minus 1.381 equals 1.000. Confirmed. Scientific calculators have sin, cos, and tan functions. In WAEC further mathematics examinations, you may need to evaluate these or use their identities to prove results or simplify expressions. Today we introduced hyperbolic functions, sin x equals e to the x minus e to the negative x over 2, cos x equals e to the x plus e to the negative x over 2, tan x equals sin x over cos x. The fundamental identity is cos squared x minus sin squared x equals 1, analogous to the Pythagorean identity but with a minus sign. Sin is odd, symmetric about origin, cos is even, symmetric about y-axis, always greater than or equal to 1. The addition formally have plus signs throughout, unlike trigonometric cosine which has a minus. For your practice exercise, use the definitions to verify tan squared x plus sec squared x equals 1. Then calculate sin 2, cos 2, and tan 2 using the exponential definitions, and verify the fundamental identity.